When it comes to dividing rational expressions, we're only a step away from converting that into a multiplication problem. You may remember from dividing fractions that we divide fractions or rational expressions by multiplying by the reciprocal of the second expression. Some people memorize the mnemonic keep, change, flip in high school as a reminder for the procedure of this. Basically, that means you keep the first fraction the same, you change your division sign into multiplication, and you flip the second fraction. The math term for that is taking the reciprocal of the second fraction. So we're going to carry out the same procedure here and then convert this into a multiplication problem and then use what we've learned about multiplying rational expressions to move forward. If I'm supposed to divide 12xy over 8 by 6x squared y over 24a, I'll just immediately rewrite this as a multiplication problem. So here's our multiplication problem, 12xy over 8 times 24a over 6x squared y. And then we begin to identify and divide by common factors. Let's look for common factors. There's a common factor of y. There's a common factor of x. 12 and 6 are divisible by 6, so this can become a 1. This becomes a 2. 24 and 8 are divisible by 8. This becomes a 3. This becomes a 1. I'm just going to rewrite it now to make sure we don't get confused and to show what remains. So I have 2 over 1 times 3a over 1x. Okay? And it looks like everything is completely simplified now, so I'll multiply across numerators and denominators. I get 6a over x. This is our final result. Even with a more complicated rational expression, we just take one step to rewrite this as a multiplication problem. So I keep the first fraction the same. We'll rewrite that part. I change division to multiplication, and I take the reciprocal, or I flip the second fraction. So the 9x squared goes in the denominator. I'm going to rewrite this 36 minus x squared as the opposite, or the negative, of x squared minus 36. Now we're ready to divide out common factors and multiply across. So let's look for the factors of each of these expressions. 3x cubed plus 15x squared. Looks like I can factor out a greatest common factor of 3x squared from this expression. So I have 3x squared times x plus 5. This denominator is a trinomial, x squared plus 11x plus 30. It factors into two binomials. And the numbers here multiply to 30 and add to 11, so that's x plus 6, x plus 5. This numerator is the difference of perfect squares, so this factors into x plus 6, x minus 6. And this is already a monomial factor, so 9x squared. All right, now that we've factored everything, we can divide common factors. So let's divide x plus 5 as a common factor and x plus 6 as a common factor. I also have an x squared here and a 9x squared here. So we divide this by 3x squared, and that becomes a 1. We divide this by 3x squared, and this becomes a 3. It looks like I've divided all the common factors possible. This fraction is just 1 over 1 now, and this fraction is the negative of x minus 6 over 3. So here's what remains in our terms, and we'll multiply across numerators and denominators, and we get the negative of x minus 6 over 3. Or you could have written this as 6 minus x if you distribute the negative sign and reorder terms. Either way is acceptable.